Welcome to Agilent SystemVue. In this demonstration video, we'll look at how multi-standard radio waveforms can be used within the Agilent SystemVue design environment to anticipate compatibility with 2G, 3G, and 4G waveforms. Multi-standard radio is called out in 3GPP Release 9 Technical Spec 37. It calls for a number of specific spectral mask and other tests to assure multi-standard compatibility, especially for base stations. Agilent makes a variety of tools for both design and test. Some of the Agilent test products that play in the multi-standard radio space are Signal Studio and the 89600 VSA. In the design space, the Advanced Design System, Golden Gate, and Genesis do RF component design, and SystemVue is applied toward system architectures, scenarios, tests, RF baseband co-design, and baseband DSP algorithm modeling. This video will focus on SystemVue. SystemVue 2011 introduced a new capability to combine multiple dissimilar waveforms. This can be applied toward MSR and interference scenarios by combining static waveforms, runtime simulation waveforms in the form of math language, C++ models, VHDL and Verilog, as well as live measurements, as well as active SystemVue subnetworks and IP reference libraries such as LTE, wideband CDMA, and others. These waveforms can be combined into a single common time-step complex envelope waveform that can be applied in a number of ways. Baseband and DSP algorithm developers can use the combined waveforms with great flexibility for exploring base station and E-node B transmit predistortion, crest factor reduction, and other baseband algorithms. And on the receive side, explore robust receiver algorithms with complex interference studies. Baseband DSP algorithm designers can also look at the bit error rate and throughput, as well as the architectural planning of the entire system. RF designers can take a waveform out of SystemVue and use it to test the efficiency, spectral masks, and EVM, as well as multiple receiver characteristics of analog components in such environments as ADS and Golden Gate. It's also possible to download baseband waveforms into arbitrary waveform generators and pattern generators to generate real hardware signals. These can also be used in a DigiRF sense and in a logic analyzer sense to provide test vectors for embedded DSP and DigiRF applications. Waveforms can also be downloaded into RF signal generators that allow, again, hardware component tests comparable to the simulation-based tests done with EDA tools. In this way, SystemVue provides symmetry between the simulation and measurement world for true model-based design. The key component is the signal combiner simulation block, which allows you to bring in multiple waveforms in different formats, each with its own time step and carrier frequency. The signal combiner component takes these various waveforms, resamples them, and time aligns them into one common signal that allows you to take that signal and do additional signal processing or download to test equipment. With this waveform, you can perform interference studies, cognitive radio, receiver verification, as well as base station testing. An optional companion to SystemVue is the Agilent 89600 VSA software. In simulation, the VSA co-simulates with SystemVue, allowing you to visualize simulation results with the same algorithms and techniques as you would use on hardware measurements. Let's see how that looks. Here's a SystemVue system where I collected several inputs and I'm combining them with the signal combiner and I'm running them through a nonlinear amplifier into the VSA software. Now, the VSA software is optional and you can see that I'm able to plot the responses, but when I hit simulate, the VSA pops forward and I can look at the result in real time. So what I'm going to do is I'm going to stretch my window so that you can see the VSA underneath, and I'll go in to the SystemVue software and tune one of the carriers to be at a different power level. And you can watch the response change in pretty much real time. With this, you can interactively explore the effect of many parameters, both signal processing and impairments and RF effects on the overall system performance. That RF amplifier in that SystemVue simulation was ideal, but I can also pull in simulations from Golden Gate, the Advanced Design System, or even X parameters, and do virtual component validation within SystemVue. I can turn around and take that same block diagram and download into an Agilent signal generator family to do stimulus response testing of a real RF device, measure it on an Agilent analyzer family, such as the MXA or the PXA, and visualize it with the same VSA software. With MSR personalities in the analyzer families, it is possible to do structured MSR testing of Release 9 devices using both SystemVue for complex scenario generation as well as the very specific standard compliant algorithms for measurement and expressing spectral masks that are present with the test equipment personalities. Finally, that combined waveform was used as part of a digital pre-distortion extraction of a 200-watt LDMOS Doherty PA that you can see the pre-distortion improved the performance of the Doherty PA by about 15 dB on adjacent channel power. This is just one of the many applications afforded by Agilent SystemVue as you design, validate, and troubleshoot your next generation wireless equipment. For more information about Agilent SystemVue, please go to www.agilent.com/find/ESOP-SystemVue-videos. For more information about MultiStandard Radio, visit agilent.com/find/MSR. Thanks very much, and good luck in your next design.